Okay, so this one. Okay, good. Today, I want to try build a regex engine. Well, firstly, parser, I think, but regex engine. There's the goal. Um, Basically, I think that regex is pretty cool, and I want to see how it works a bit more, like under the hood. So I want to try build my own engine. So, what is regex? So, just in case, just to give a brief introduction, regex is essentially short for regular expressions. And the way I would probably explain it is if you think about like, so I spelled dictionary wrong, but I have a file, dictionary, which is like one of those text files you can download or copy and paste from this kind of site, right, with a bunch of words. So if you think of like Control F, right, like normal Control F, without any things, any special features, you use it. Everything's caps lock, but you use it to look for particular sequences of characters, right? So like if I want to find all the words that have like bard in it, I can go to Control F and bard. Yeah, I can find all the words that have bard in it. Fantastic, and that's cool, and that's fine. What regex does, and that's what this option allows. What regex does is it allows for the use of like wildcard characters. So instead of like BARD, which again is those 14 words I have, what if instead I wanted to find all the words that had BAR and then any character, so D or X or G or whatever, any character. Instead of putting any specific character, I can put a full stop or a period, and you can see I've got 153 matches. And the reason is because now I'm matching a lot more things. You can see here, I don't know what, I'm assuming that says, okay, Barb. Barb was that one. There's Barb, there's a lot of Barb. Okay, fine. We've got Bear, B-A-R-E, so it's matching an E as well. Bog with a G, bark. Go down a bit more, etc. Right? So like, what else is there? Anything else interesting? Do I have to keep doing this? Barn, barrel, B-A-R-R, like that, etc. Right? So the dot in this case is able to match any character I want. And then the other like typical thing the other typical character is like an asterisk, which basically means 0 or more. So what this is saying is find all the words that has a B, an A, and 0 or more R's in it. 0 or more, which is important because what that means is you can see in this case, it's matching just the BA in a base or in abandons because the star means 0 or more. So it doesn't have to be an R in there. There has to be a B and an A, B followed by an A. There does not have to be an R. But if you're gonna have an R, you're allowed to have as many R's as you want. I don't know if, because words generally aren't gonna have more than 2 letters, like a double, like they're not gonna have, I don't know what word has 3 R's in a row, so I won't be able to show that. Well, I guess I can just make the words up. So if I get rid of all this, if I have BA, that matches, you can see it goes orange. BAR, that matches. BARR, that also matches. BA, that matches. It's only if I don't have an R in there, right? If I put an X instead, then the whole thing won't match. The BA does match because, again, if there's no R, that's fine. So the BA by itself matches, but because of that X, the X and R don't match. If I get rid of the X, then the BAR matches. So those are like the two operators that I think are most, not common necessarily, but like the easiest ones to explain just from this kind of file. But there are other operators. So from this site, regex1, you get like a pretty good overview as to how regex works and how you can work with regex. And there's a bunch of different features. What I just did was I just tabulated kind of all of the major features of regex, of like normal regex. So the one, and then I bolded the ones that I think I will likely try to implement. So you got letters and digits, as you'd expect, being able to use being able to use any letters you want, any digits you want, English letters that is, full stop that we saw before, or period. There's also the escaped full stop, because if full stop represents any character, then what if we want our control F to have an actual full stop? Like what if we're actually looking for full stops? So the way regex handles that is we put a backslash before the dot, and then that means what does that mean? That means that it's the actual full stop that we're looking for. There's a bunch of others, there's grouping kind of things, there's grouping ideas. There's like these little special escape characters. There's repetitions that you can do like this, instead of like if you want a specific number of a particular character, you can use like the curly braces. If you want up from M to N repetitions, you can do this. But I'm not going to bother with that. All I'm going to care about is the star, which is 0 or more repetitions. There's also a plus and a question mark, plus being 1 or more repetitions as opposed to 0 or more. Question mark referring to like optional, but I'm not going to do those yet. Those aren't, I imagine those won't be super hard, but to add, that is, like after I have the initial architecture, but for now, I'm going to leave them. Probably the most controversial thing I'm not including, not controversial, as in it's controversial that I'm not including because I think they're very useful, are these two. Let's say you're looking for a particular character, a particular pattern, but you're looking for it such that it exists only at the start of a line. So like, let's say I'm looking for BAR, but I only want to find words that start with BAR, not any others. So like Zanzibar, is that an N? Yeah, Zan, right? Yeah, Zanzibar shouldn't count because I want the BAR at the start. So you can use the caret symbol. Whoops. I can use the caret symbol to indicate I only want the ones at the start. And what if I only want BAR at the end? Then I use the dollar symbol at the end of the thing to show that I only want the BAR to be at the end. And then we'll match all the words that have BAR at the end. So I think these are quite helpful, but for now I'm not going to bother with them because I just think I don't want to. Finally, we have two things I didn't talk about: capture groups, because what I'll talk about in a sec is these different operators. That's what they are, right? Operators like the star, and concatenation technically is an operator, and we'll talk about this guy as well as another operator. They have precedence. So like the way that you do multiplication before addition, multiplication has a higher precedence, we say, over addition. In these, certain operators have precedence over other operators. So grouping, just like in math, these brackets can be used to specify the order in which you want operators to be applied in, if it goes against the defined precedence order. And finally, we have this guy, the pipe symbol, which is like, I think they call it, what do they call it? Alternation. It's basically an OR. So imagine I'm looking for words that have BAR in it, or TIM. Okay? So we have all the words that we saw before, but we also have Baltimore and, but we also have Baltimore and bedtime. Because what's happening is I'm looking for words that either have a BAR in it, BAR, or a TIM, right? So if a word has a BAR in it or it has a TIM in it, then it counts. So bedtime counts because it has a TIM. Barley counts because it has a BAR. So in that sense, so this can be quite useful if you're like looking for specific, a certain set of sequences that really have nothing to do with each other. So yeah, that's that. And those are the basic. That's the basic idea. So yeah, the things I want to implement is the pipe, the capturing, the brackets, the asterisk, and the dot, and then of course the backslash stuff as well. And obviously digits and letters goes without saying. So that's what's happened. This table I got from here. I think this is like, I don't know who these people are, but it's IEEE. Oh, okay. Well, it's the people who run everything. Okay, fair enough. Basically, these guys have a lot of documentation on regex and stuff, and that's cool. Only thing I really went on this site for, I got referred to it from Stack Overflow. As in, I didn't. There was an answer on Stack Overflow already that I used to find this table that talks about the precedence of the operators. So the ones I've highlighted are, again, the ones that I care about. I'm not going to be bothered with the bracket expressions or anchoring like I talked about, anchoring all the correlation related bracket symbols, whatever that is, yet. The ones I care about are the ones in blue. So didn't need to tick that anymore. Okay. So escape characters, backslash we talked about, sometimes a backslash dot. You can also do like backslash n, I believe, for new line, and backslash t for tab. There's also backslash s, which I'm thinking about doing. I don't know if I bolded it, but backslash s lowercase s can be helpful. This one, because it matches to any whitespace character, which you don't necessarily need, but it is helpful. So those are escaped characters. Those, if you consider that as a particular operator, the backslash as a particular operator, that has like the highest precedence out of the ones I care about. So that's like the operator you would apply first when looking at a regex expression. And then you have grouping. So, brackets, as you'd expect, is quite high up because that's generally what we use to very explicitly specify the order of the operations that we want. The only thing that's above that is escape, because it wouldn't really make sense to do like this. Like this is confusing more than anything. In fact, this is an escape sequence. So it wouldn't make sense to like try and group a B in a way that, this wouldn't make sense. So escape characters are at the very top, and then grouping is just beneath it. Single character ERE duplication, so there's the asterisk and a few others, but we care about the asterisk. Is the next thing in the is the next operator in our list. Concatenation, so this isn't an obvious operator, I think, but the idea of like, if I'm looking for BAR, we can imagine that the B is concatenated to the A and is also concatenated to the R. Like there's an operator being applied to each individual letter. If each letter is like a unit in our did I say operator? If each character in our regex expression is a unit, then you can imagine that this expression is the result of concatenating these units together. So that's like another operator that happens after the duplication. And finally, alternation, which is the pipe symbol, is the lowest precedence. And I actually didn't know that before I read this. As in, I maybe knew that at some point in my life, but I didn't remember that. So I'm glad I found this table. So just to clarify what that means, like why this is important to understand. Imagine you have BAR versus what did I say, TIM. Okay, so what this matches, this would match BAR or TIM. The reason it matches that is because the concatenation is considered first and the pipe is considered after. If the pipe was considered before concatenation, then what this would match, when writing this, what this would match is BARIM or BATIM. Like if this happened first, if this had higher precedence, because we would apply this operator first onto these two characters and then do the concatenation of everything. So in other words, maybe this is, I don't know if this is clearer, but in other words, this, by the precedence rules, this is equivalent to BAR in brackets, TIM in brackets. As opposed to if this had the higher precedence, then it would be BARTIM, right? But this is wrong. This is not what happens because the precedence of the pipe is lower than the precedence of concatenation, right? So that's the kind of idea. Now, building a regex engine, I did like a little bit of research on how it's done, but not enough to be confident. I'm kind of just completely guessing. But in my mind, my understanding... Oh my god, I did it again. I'm trying to delete this thing. My understanding is... This isn't the lasso. Maybe it works. Aha, nice. My understanding is I have to first build a parser. Because, like... the general gist, if we think about regex in terms of without any special characters, right? What I'm going to be doing is like, I'm going to give some characters. I'm going to go through each word. I'm going to go through a file or a text or whatever. And I'm going to ask, okay, can I find a BAR in here? Can I find a BAR? Obviously, as a human, we can say no very quickly, but a computer will have to iterate through each character one by one, right? And and until it finds a B, it's gonna like keep skipping over and over and over again until it actually finds a B, like that one. It's gonna say, hey, that's a B, and then it's gonna look at the next character, hey, that's an A, and then it looks at the next character, hey, that's an R, and that's fantastic, right? And then we would say, we found a match, great. The issue is, what if like I want something like this, BA pipe T, and I'll, just for simplicity, I'll put a bracket, right? So I find a B, this is a great example. So imagine I find a B, I find an A, and that's great, that's what I want, and then I see an S. And like the idea is, well, I have to check if S, the character here, matches with like the group here. And in this case, it's easy. I just check, is S equal to R? No. Is S equal to T? No. But what if there was like some arbitrary number of stuff here? How am I supposed to programmatically figure out if the next character, the S, matches that group, right? So I need to basically break down the expression into like little subcomponents that each have their own kind of match strategy. If it's just a letter, then yeah, just check that the letter matches. If it's a group like this, then I need to be able to write up some way of checking each sort of individual sub-expression. Because imagine like, this might not even just be one letter, this could be like a bunch of stuff in here, or whatever. I have to be able to check if after I match the B and I match the A, I have to check, does the next thing match this guy? Where this guy means either matching this person or this expression. Not a person, this expression, or this expression. So like I have to really be able to break the overall expression down into individual, what I'm calling sub-expressions. So I think I need to first build a parser that is able to actually break down the expression into little sub-expressions first, and break those sub-expressions down into smaller sub-expressions where required. So like the B would be one sub-expression, A would be another sub-expression. This bracketed thing would be another sub-expression. But then within that bracketed thing, this would be one sub-expression, I think, and then this would be another sub-expression. So the ability to check if this guy is a sub-expression depends on my ability to check if, this guy is a sub-expression and this guy is a sub-expression that matches. I said that wrong, I think. I meant to say that for me to be able to check if this guy matches a character, I have to be able to check if this guy matches a character and if this guy matches a character. If you're comfortable with design patterns, I believe this is the composite design pattern kind of idea where you try to build a tree out of a particular expression and then evaluate the match status, whether it matches or not, by like checking the leaves and then bubbling the result up through the tree. But yeah. So I did a compiler course, or I'm doing it, sorry, we're nearly done. So I learned about like how we take source code and like try to convert it into a set of tokens and then build an abstract syntax tree and blah, 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 like basically the tree that I'm suggesting now. And then only after we build that kind of tree can we actually check, well, first of all, is it a valid regex or a valid source program? And then from there, actually being able to interpret it and make source code out of it, machine code, out of it. So I think we can do something similar where we define a kind of method or procedure for building a tree of sub-expressions. And that first requires me to define a grammar, So I've done that to the extent that I think is correct, but it's a bit weird, and I'm not necessarily confident that it's correct. But if we were to work through it, basically, you have expression, right? Which is the topmost line in the grammar, which means it's like the most abstract idea, so to speak. It's like, expression refers to the overall, well, expression, right? Whatever I'm typing in here, for example, like arpeggio, that would be the whole expression. I use epsilon to represent the empty string. We were taught that in the course. I don't know if that's something that happens everywhere, but yeah, epsilon means empty string. Because technically speaking, an expression could be an empty string, I suppose. So empty string. Otherwise, we would expect an expression to be composed of a sub-expression and then what I call an OR expression. So, and just to clarify, an OR expression is either the pipe, right, the OR symbol, the OR operator, followed by another expression. And the idea is, if you think about this recursively, if I was to substitute, this guy with this guy, right? Specifically, if I was to substitute this guy with this guy, what I would end up getting is my expression is defined as a sub-expression, followed by a pipe, followed by another expression. Where expression could be another sub-expression, followed by an OR expression, where OR expression in turn could be a pipe followed by, another expression, which is sub-expression, followed by an OR expression, which could be a pipe, and then so on, until eventually we run out of pipes in our overall expression, in which case the OR expression would just be the empty string, so nothing. And that's how we terminate. It's basically this kind of recursive idea that lets me, like the way writing it like this means I can basically, my expression can be defined as a bunch of sub-expressions separated by pipes. And I'll try to explain this a bit better later on, but the fact that pipes are the lowest precedence operator is the reason why we define an expression as a bunch of sub-expressions separated by pipes. We always choose like the next lowest precedence operator for like the separator of the overall string or whatever. Okay. So I don't know if that made any sense. I don't think it did, but what can we do? So yeah, sub-expression can be empty string. It can also just be, imagine, whoa, what did I just do? Okay, sorry. It can also just be one sub-expression with no OR expression. Because I define the OR expression to be able to be a pipe followed by an expression, it can also just be the empty string. So if you give a pattern, regex pattern, that has no pipe in it, then the way it would get broken down is there would be one sub-expression, and the OR expression bit here would actually just be the empty string. There would be no OR expression. Okay? So, yeah, it's very flexible. Basically, in essence, expression is either empty or it's a bunch of sub-expressions. It's either empty or it's one sub-expression or it's a bunch of sub-expressions separated by the pipe operator, by the alternation operator. So that's what an expression is. Cool. What is a sub-expression? So we talked about what OR expression. Sub-expression can either be empty, just, I think it's kind of like a necessity, or it can be what I call a char. I might have to change that name because that's a bit generic, but it can be a char followed by another sub-expression. So this expression definition basically like these two things together, the OR expression and the expression, handle the pipe, the alternation operator, right? This guy, char sub-expression and char, no, sub-expression specifically, handles the concatenation operation, right? I'll explain now. Char is basically just like a bunch of characters glued together. Well, there's also this, but char is a bunch of characters glued together. Oh wait, this is wrong. This shouldn't be here. Okay, I need to fix that, I think. Yeah, so char is basically a bunch of single characters glued together. Sorry, I'm just not sure if my grammar's correct anymore. Yeah. So yeah, char could be like a so char is just a single character, maybe with a star or maybe not. It depends, but it's sort of at most one character and at most one star. And so by doing this recursive idea with char subexpression, you can think that subexpression could be replaced by one of these guys, right? Because subexpression can be defined as one of these guys. So char subexpression could become char subexpression, which could become char subexpression, which would become char subexpression, until eventually we terminate by making subexpression become the empty string. So this definition here lets me build a bunch of characters, basically. I wonder if it would have been easier to define it bottom up as opposed to top down, but I don't know. Now, to be more specific, this happens sometimes. Why does it always go back to the pen? I don't want the pen. If I wanted the pen, I'd click the pen. Give me the lasso, man. Thank you. Okay, very good. So that's the concatenation. So char, I've defined, this is the bit that basically lets me, this is the bit that lets me do the, this operator, the star operator, the duplication operator. Right. So a char consists of a single char, which, yeah, could be like a single character or an escape sequence. It could be a single char followed by a star, where a star, confusingly, can either be an asterisk or the empty string. So it's a way of making the star kind of optional in the grammar. So, no, don't do this to me again. Okay. So, yeah, if subexpression is a bunch of chars glued together, a char is a single character, single char, followed by a potential star. So, you know, A star, B, C, D, for example. This is one char, single char followed by a star. This is another char, single char followed by a star, because a star I've defined to be either a star or an asterisk or the empty string. So in this case, the star is just the empty string, and same with this one, and same with this one. But if I had E star, this is another char instance with a single char, which is the E, followed by a star, which in this case is the asterisk. Okay, so in this way, a char is either a single character by itself or a single character followed by a star. So that's the idea there. Now the bit that I'm not sure if I'm going to do correctly is the grouping part. So I've done most of the operators. You can see I've done the bottom thing, the alternation I've done, the concatenation I've done, this one. Grouping, I'm not sure if it's going in the right place right now. I put it here, but I'm worried that I've messed up a little bit by putting it there. Anyway, I'll think about that a bit more. Single char, this guy over here, is equal to either literally a single character. To be super accurate, what I should have done technically is like literally written like hundreds and hundreds of these arrows, doing every single character, G, H, and so on, you know, doing the lowercase stuff as well, doing numbers, doing, you know, all the symbols, any characters that don't have any special meaning, for, exclamation mark probably, I don't know if that has meaning, ampersand. I should have done everything. So I've summarized it by saying single character, which just means a single instance of any and every character that doesn't have any special meaning. Or maybe even if it does have special meaning, I think I still would count it as a single char. Maybe I'll write that separately. Just put the dot as another one of the single chars. Because like, that's like the wild card single char. So I think that's fair. Star we've already talked about. It just means it's actually an optional star. And then escape character, because single char can also be an escape character, right? \n, \t, \dot, /star. \dot means we're looking for an actual dot, full stop. \star means we're looking for an actual asterisk. Right, so in that sense, we've managed to build a grammar that I think summarizes regex, at least the subset of regex that I want to implement. The only thing I'm trying to figure out, so char, you can see I've said that char can either be a single char followed by a star. I also said it could be an expression wrapped in brackets. This is a common strategy for dealing with brackets, is like generally you put the brackets and then you put like the most abstract idea inside the brackets. So expression is the most abstract idea, is the most abstract thing that you can have. My only issue is I'm wondering, because brackets are meant to have a higher precedence than stars and a lower precedence than escape characters. So I'm trying to figure out if I should have made another sort of type over here for the bracket specifically. Because I'm worried like I've given brackets and stars, the duplication operation. I'm worried I've given them the same precedence. I don't know if I've done that. So for example, if I have a thing, an expression, a regex expression, like I don't even know would this break if I have like bracket A B C star. So what would happen in this case? Yeah, I think it's wrong because I've only ever used the star. Maybe I need to have a star here as well. Because like, okay, I have the whole expression, which can be thought of as a single sub-expression because there's no pipe. And then sub-expression is a char followed by another sub-expression. Oh, this is wrong. Okay. Oh, no, it's not. Is it? No, it's not. No, it's not. It's a char followed by a sub-expression. So the char in this case isn't actually a single char, it's this whole thing. Because a char can either be a single char or with a star, which it's not, or it could be an expression wrapped in brackets followed by a star. So I think I get away with it if I think this correctly summarizes the grammar. I need to have a star in here, so in case they put a star after the brackets. So just to clarify, what this matches is A, B, either not, first of all, it matches the empty string because again, star means 0 or more, so maybe you don't have any ABCs, or you could have a single ABC, or you could have 2 ABCs, or you could have 3 ABCs, or you could have 4 ABCs, and so on. So that's what that means, and so the idea is stars should be applied. Wait, does that mean stars has a lower? Oh no, that's right. Yeah, sorry. Stars has a lower precedence because you apply this operation first and then apply the star. Yeah, sorry, I got confused between stars and the escape characters. And I guess that makes sense because here, like, you will read this first and evaluate it before doing the star. Unless you really want, hang on. All right. All right. Here's what I'll do. I'll make another non-terminal. The left-hand sides, like things that I've written in blue are called non-terminals because they're like abstract ideas that don't terminate. Like the physical characters, like the brackets and the pipe and the epsilons and stuff, those we call terminals because they are like the actual things you're going to be seeing. The terminating ideas, the most concrete, non-abstract ideas. But the abstract stuff I'm writing is we call non-terminals. Anyway, okay, what I'll do is I'll say a char consists of a what did I want to do? I already forgot. I want to make it such that the duplication operator is not in the same vein as the brackets operator. So I think what I want is for char to be a block, these are horrible names, followed by a possible star. So this does the duplication operation for me, and that's what a char is. And then a block is either a single char or a bracket. And I think this solves my issue. So this is for the duplication operation. This is for the grouping operation. And finally, a single char can either be a literal single character or an escaped character. And this is the escape operation. So that, I think that's correct grammar. And I think it might be worth showing a run through of how this grammar kind of operates and how it builds a tree. But before that, actually, what I'll say is, you'll notice that the grammar that I've written from top to bottom has the lower precedence operators written first and the higher order, or the higher precedence operators written at the bottom, which might seem a bit counterintuitive. You might think that surely the operators that happen first should be written. Give me the lasso, man. The operators that are written first should be written in the grammar first, right? Like, you know, the grouping operator has a really high precedence, right? The grouping operator brackets has a really high precedence. So why is it written so far down? I think the easiest way to explain this is with an example. I kind of was thinking about this earlier anyway. But if you imagine this expression, like, you know, a math expression. So through 2, just copying myself, 2 plus 3 times 4. As a human, we kind of intuitively know to do the multiplication first and then add the 2 at the end to get 14, right? But as a computer, like, naturally, we're probably going to read from left to right, so we're going to see that plus first, right? We're going to see that plus first. So what we think is, okay, we know the plus is there, that's fine. We know that because plus has a pretty low precedence, like it happens kind of at the end of math calculations, we should probably figure out what's on the left-hand side of the plus and the right-hand side of the plus before we actually do the plus operator. So as a tree, you might draw it something like this. You have a 2, and then you have, you know, 3 times 4. And then from there, it's the 3 times 4 that has to be calculated first. So kind of do something like this. So we've kind of built a tree where, you know, the plus is at the top. We're going to do 2 plus, and then 3 times 4 is how we would represent this as a tree. Notice that the plus, which is the lower precedence operator, appears at the top of the tree, because even though it has low precedence, it's the thing that it's going to be the first thing we use to split apart the expression into different sides. And that's kind of what's happening here. So in essence, by writing the low precedence operators first, we're using them as the first sort of symbols, I guess, to split apart the expression into more specific regions that will then be calculated first, right? And then this is what I meant by, like, before I said, oh, you know, generally we build a tree, it's composite pattern, we bubble up the results. Basically, you know, we first would start at the bottom. You know, this is a 3, this is a 4, we bubble up. We know that we have to multiply the numbers, so we look at the children, get 12, and then we go over here, this is a 2, this is a 12, we know we have to add the numbers, so we get 14. So that's what I meant by from the bottom, we bubble up the results to get the final result. So that's all that is. Now, to do something a bit more complicated, let's use the grammar that we've defined to build a tree for a particular example. So I think I had an example in mind. I missed. Okay. So I had an example, yeah, so like something like this. So imagine you have, so as an example, as an example, let's say you have an expression RK star A slash BC bracket. I don't know. Let's just do that for now. So as a tree, we know that we have an expression. I'll use we know we have an expression. That's like the topmost node, right? That's like the most important idea we have. But how are we going to split this expression? We're going to first have, using our grammar, we're going to have a sub-expression. And we're going to have an OR expression. That's by definition, right? The topmost idea is an expression, and then we have a sub-expression, which can be broken down into a sub-expression or an OR expression. Because we know it's not the empty string, so that's how we would write it. Now, the sub-expression can be written as char followed by a sub-expression. Char followed by a sub-expression. I'll just write sub now, right? The char is a block followed by a star. A block followed by a star. A block can either be a single character or an expression in brackets. In this case, it would be a single character. Single. And the single character can either just be a single character, an escaped character, or a dot. In this case, it is the single character R. So in red, I will say this is an R, concrete, right? And I might just change this to say \n. And I might change this to say dot, because I want to use the different characters. Okay, so we have this tree, sub-expression, we sort of broke it down, a block becomes a single becomes R. A char has a block and a star. In this case, there is no actual star after the R, right? There's a star after the K, but we haven't gotten up to that. It was the star after the R. That's why we defined star to either be an asterisk or the empty string. In this case, the star should be the empty string. Fantastic. Next, we have the sub expression. Maybe I should write the full thing. A sub expression is a char followed by another sub expression. That's true again. It's a char followed by another sub expression. I'm going to need more space, I reckon. A char, we said, is a block element and a star element. A block can be a few things. It can either be a single char or a expression. In this case, it is a single. And a single can be a few things, right? A single can be a single character, an escaped character, or a dot. In this case, it is just a single character, K. And the star is actually an asterisk this time, right? It's K and then a star. So the star isn't the empty string this time, it's the actual star. Now we have another sub-expression. It's, wait, a sub-expression is a char followed by another sub-expression. That's from the production. That's from that grammar. From the grammar, the char is a block and a star. A block is a single character or a thing in brackets. It's only a single. And in this case, the single is the escape character, I believe, right? I said \n, yeah. So this guy becomes \n. Cool. And star, of course, is empty because there's no actual star. And this sub-expression over here is the empty string, right? Because the sub-expression can either be this whole thing or the empty string. And that's why it's important to have these empty string definitions, because at some point I need to terminate the tree. So sub-expression is a char and a sub-expression, which is a char and a sub-expression. And eventually sub-expression is just the empty string. Now the OR expression, over here is a pipe followed by an expression. So it's a pipe followed by, gotta try to give myself some space, by an expression. Expression, of course, is a sub-expression followed by, along with an OR expression. All right, looking at our grammar. Sub-expression in this case would just be a char followed by another sub-expression. The char has a block and a star. The block is just a single. The single is just a B. Star in this case is empty. The sub is the dot thing. Okay, hang on. The sub is a char and another sub. The char has a block and a star. Block has a single character. And that single character in this case is a dot. So single in this case refers to the dot. Yep, there's the dot. Star is empty again because there's no star. Sub is also empty because we did sub expression, which got me the B, then another sub expression, which got me the dot. Now, we're requesting another sub expression, but there's no more characters left, so it's just the empty string. And we bubble all the way back up, and eventually we'll get up to here. The OR expression here is just empty because there's no more pipe symbol to work with. So quite a complex tree we ended up getting with all these different nodes. But we can see that if we were to sort of look at all the kids, all the leaves, we would get like our thing back. K star backslash n, an empty string, another empty string. Oh, okay, I should ignore the empty strings. Pipe, and then B and dot. So yeah, if you don't think about the empty strings, because the empty strings are literally empty, they don't fill in any space, you get back your original string, original pattern. So that's quite cool. And you might ask, what's the point of making this tree? Like, if it's all it does is give you back the original. Like, the idea is, you can imagine if this is like a tree that I have in code. You can imagine this node has a match, a match method. So I ask, okay, which returns a boolean, right? True or false. Basically asking this guy, hey, do you match a particular string? Get some input string. Do you match? What he would do is, what this node would do is ask, okay, let me ask my kids, do you match? And do you match? And for you to match, you have to match, and then you have to match or something. Wait, how would I do this? Yeah, the char has to match, which means you have to match, and then you have to match. I believe that by doing this, you are able to sort of bubble through the matching and make sure that everything matches as expected. And Yeah. I hope this is right. As in, I think I'm confident in the grammar making sense. I don't know if I actually had to do all of this. So if I have an expression and I want to say, hey, do you match a particular string? What would I do? I would call expression.match, and then I would check if for a particular, I'd have like a pointer pointing to the start of the string or whatever. And I would ask, do you at the pointer match with this sub expression? Which would mean, do you match with this char followed by this sub expression? If the answer is yes, for this char, then we move the pointer along. If the answer is no, then we know that the match didn't work. I think it makes sense. I'm pretty sure. It's hard to explain without like actually working through it, but I believe it's important to break the expression down into like tiny, teeny pieces like this, where I can kind of check the low-level ideas, like the actual terminals, and then bubble them back up to combine the ideas to make more abstract claims. Okay. Well, anyway, from there, we need to actually build the parser. God knows I'm going to be making mistakes, so I'm going to need to be able to print stuff. Wait, what? Isn't this a thing? Is it bool on it? Huh? Wait, is boolean? Is it just here? I could have sworn there's a boolean. What? Okay. Oh, my bad. Okay. So, I'm gonna need hella structs, I think. So we'll do int argc chars. It's an array of strings. Yes. If argc is not equal to 2, then fprintf the file pointer, standard error, and then the m message is usage parser followed by regex expression backslash n, and then exit 1. Very good. So that's just making sure that I have the string, and then basically the char star regex pattern is equal to argv at index 1. Do I have to, is that a magic number? Do I have to like make a constant or something? Is that fine? Is that good practice? Was that stupid? I don't know. Okay, so I have all that, which is fun. So I have a pointer pointing to the pattern, and then basically I need to define like some functions to get me like the next character. I need the function to get me back go back a character maybe in the pattern, etc. I can assume it's null terminated because that's how things work. Okay, so I have to pass I need to make a passing function for each of these, right? It's a good thing the grammar is not complicated, because if I did this before for the compiler course. If I had to, and that was annoying because there's way more of these things that I had to pass. Okay, let's see if this works, shall we? Let's just make everything void for now because I can't be bothered thinking too hard. Pass expression. It's a function that takes in the current pointer. Maybe? Is that it? And return. I'll just make a bunch of maybe I should make a bunch of thingies first. What are these called? Void declarations? Function definitions? Void pass or expression. Char star regex pattern. Whoa. Okay. Pass sub expression. Pass a char. I need to think of a better name. Char is terrible. Repeated. Well, we care about the star thing, so pass where's my pen? Oh, there it is. Repeated block. Pass a repeated block. Pass just a block. Pass a single char. Even that's not really correct because I guess it is actually, because I mean escape is kind of a char. Yeah, that's fine. I can get behind that. Pass the star. Pass the escape char. Okay. If nothing else, this will make sure that the regex was probably written to match the grammar. So, if someone writes something dumb, then it won't work. Did I get all of them? 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Very good. Now we give definition. So we've done declarations. Now we do definitions. So what do I have to do? Well, I'm trying to build a tree. Oh no. Maybe like a... Wait, how do you type def stuff again? How do you type def? Oh, I'll figure it out later. Struct expression. It needs to have a pointer. Again, can I just have definitions? Struct expression, struct or expression struct. Maybe it's better just to say or expression. Struct sub expression. I don't know if I don't know how to do all this. I like to have things written down. Yeah, this should say repeated block. Struct hey? What am I up to? Sub expression, repeated block. Struct normal block. Single star. Struct blocked. Struct block, struct single char. Struct star, struct escape Charles. Okay. So, I don't want to do this. Is it going to be like... Well, it can either be empty or this. What does that mean? It needs to have a pointer to a sub expression. No, that's annoying. How do I do... how to use type def with structs in C? Type def this... Oh, okay, good. Wait, can I do it like here? I could probably do this. Does that work? So if I say, does that work now? Does that work? Expected an identifier. I might regret this later, but I'll see if this works. Oh no, wait, I lost the letter. Okay. What? What did I just do? Okay, I don't know if I did that correctly, but anyway. Sub-expression, or expression. But then, like, it also should be able to be empty, right? So what does that mean? If it's null, I guess? I'm confused. Struct, okay, let's just start there. So instead of returning void, I think I want to return an expression pointer. My bad. Oh, that's going to be wrong. So if I want to pass an expression, I have to try pass the sub-expression given char star regex pattern. Wait, what am I doing? and then I have to pass the OR expression. Okay, I should change these. This should say OR expression pointer, sub expression pointer, repeated pointer, block pointer, single char, star, skate char. Okay, so probably the easiest one to do would be like pass so in this case, all I would have to do is say if boolean empty. Is that fair? If regex pattern equals an asterisk, so I need to malloc size of star struct So this is my understanding of what has to be done for star. Is like you figure out. Oh, and you should also regex pattern. You should increment. You should move on to the next. You should move on to the next thing. Wait, what's wrong with this? Expected a semicolon. My bad. Sub expression. Size of expression E equals that, E O equals O, that's the OR expression. These are terrible names, by the way. My sub expression and my OR expression. And I return E. For small, tiny functions, it's fine. Not really, but it's fine. So if I pass the expression, I should be able to pass the sub-expression and the OR expression. If I want to pass, again, maybe passing the OR expression would also be pretty easy. Because it's just, so if regex pattern is equal to the pipe symbol, then do this. struct or expression. I can have boolean is empty, and then I can have a pointer to E, right? Then I should say regex pattern plus plus, should move the pointer along, and then I should pass the expression. I should say expression star E is equal to that, given the regex pattern. And then I should also malloc. Oh, what? Is empty equals false, because it's not empty, because we found the OR. Expression equals E. What's wrong with that? Oh, my bad. I must have. Yeah. Oh no. There we go. Else, if it's not a pipe, then it indicates that there is no regex, there is no OR, in which case O is empty is equal to true, and O expression equal to null, I guess? That should be fine, right? And then return O. Cool. Okay, so I've managed to pass U a U. Tick that off, tick that off. Sub-expression now. Pass sub-expression. Given, wait, what? Okay, so sub-expression sub is equal to malloc size of sub-expression. I didn't give a size, did it? Because there's no definition. Sub-expression. So a sub-expression is either empty or it has a repeated block followed by another sub-expression. So wait, when is sub-expression going to be empty again? Sub-expression is going to be empty if the character that that's being pointed at is not a valid start to a sub-expression. So for example, if the current character we're pointing at is a pipe, then it doesn't make sense for it to be a sub-expression because a sub-expression can't start with a pipe. So a sub-expression is either empty or it's a repeated block, which starts with a block, which starts with a single character, which is any character other than, so I need exclusion criteria. Sub-expression. Yeah, okay, so if regex pattern, for now I'll just say is equal to a pipe. We learned about like first sets and next sets or whatever, follow sets and stuff, so that's kind of what this is requiring, but I'm lazy. I.e. if regex pattern points to a character that a sub-expression could not possibly start with. I just realized I did camel case or Pascal case or whatever, and then I did camel case, and then I did snake case. Is that a bit dodgy? I don't remember. Oh well. Then s at is empty is equal to true. It is empty. A repeated block is equal to null. And the next sub-expression is equal to null. Because like, if I look at my example, yeah, so for example, like here, I had all the sub-expression. I had sub-expression after sub-expression after sub-expression. I had 3. 1, 2, 3. And then the fourth one, which came because of the tree, should say, you know, is empty is true and point to null stuff. Okay. Else, if it's not, if it does point to a valid start, then I think we can pass the repeated block. Given the regex pattern. And we can also then pass the star. Wait, sorry, we can pass the next sub-expression. Okay, repeated block R sub equals that. No, I can't do that. Child S. How do I? Pretty sure you can select all variables or something, but I can't remember how to do that. And then S sub, is empty is equal to false. Sub repeated block is equal to R. Sub expression is equal to the child sub. Cool. And then we return sub. I'll put this at the top. It's like should be immediately declared. Okay. Passing repeated block. Nope. Repeated block. Pass a repeated block. Okay. We have to malloc. I didn't define it yet. It has a block and a star. Okay. Just realizing I'm going to have some troubles in a second. Not for this method, I think, but for the next one. So passing a repeated block, I have to pass a block. Then I have to pass a star. Whoa, I did not mean to do that. Cool. Pass the repeated block. Let me to pass a block. Now, passing a block is going to be difficult. Because there's two types of blocks. There's a single character block and there's a expression wrapped in parentheses kind of block. And there's no such thing as inheritance in C, so I can't leverage that. So what can I do so that a block can either be pointing to a single char object, which is this guy, or an expression object? I could have two pointers and one is null, one is not null. That's kind of annoying. Block, single char, expression. Basically what I have to do is, that's repeated block, so block, pass, block involves if where the regex pointing to is a bracket, is an open bracket, then I have to increment, I have to say expression E is equal to pass the expression that exists given the regex pattern. I have to ensure regex pattern points to the closing bracket, closing parentheses. Bracket is fine. It's not like we're using actual brackets here anyway. And then regex if regex pattern is not equal to the closing parentheses, fprintf stood error. I believe that the brackets were not closed, mate. And then exit on. I think. I can make a generic match function as well to do this for like generic characters as opposed to specifying every time. But for now I'll do it like that. So yeah, if it's like that, then I have to do this. Can you like store types or whatever? Like struct block. We know it's either going to be pointing to an expression or a single char. Because the grammar is small, I can get away with just having two pointers and one is always null and one is always non-null. But that just feels really ugly. Surely I can do something a little bit cleaner. This is where my lack of knowledge in C becomes a problem. I have single char, I have expression char. I mean, what? I have expression thing. You can't have void stars in here, right? Can you? Nice. Okay. Maybe some kind of enum. How do I define enums again? Like, type def enum block type block type. It can either be single, so commas, or it can be an expression type. Is that fair game? Oh dear. So you have a block type. And then you have your pointer. So we'll use the block type as a way of casting, basically. Very manual way of casting. Void star. I don't even know what to call it. Data. Wait, where's all my stuff? What? Parser repeated block, parser block. Parser expression should be way higher up. Parser block. So yeah. If it's a bracket type, then I need to malloc as well. Malloc size of block. Whoa. What did I do? Block star b equals that. B. No? Block has no, yeah, I know. It's because it's like things I'm already answering. Type is equal to. Did that work? Block type? What? Can I access enums through here? No? Worth a shot. So it's an expression type. Oh, I don't like that enums aren't scoped. I thought they were scoped. I forgot they're not scoped. Can you scope enums and see? I thought it's easier to. Okay. Manually adding a prefix. Fine. BT. Should get an error. There you go. And then else B type is equal to BT single char type. Okay, so B type. Pass the block else, so otherwise it's not an expression type that we have to think. We have a single char. I have to say B data is equal to E. B data is equal to pass a single char given the regex pattern, and then I should return B for block. Sub expression. Put this here. Is this file humongous and should I split it into different sections? Like multiple headers and multiple C files? Yes. Will I? Probably not. Single char. Pass single char, regex, char star, regex. No. Single char star s equals malloc size of single char. It didn't work because I didn't define it. Wait, what? Oh, I tripped out, sorry. Single char. Oofed. Boolean is escape. And then char data or whatever. Like, what character is it? Yeah, wait. So if I want to make an escape char object, then it should point to that escape char object. Escape char. It shouldn't be it should be a pointer, not a char. But I need a char as well in case it's not an escape char and it's just a single character. Okay. Screw it. What's this called? Escape char? Pointer. So similar to escape char. Similar to like this guy where it's conditional, it's based on the type. Either this will be like nothing and this will be a pointer, or this will be null and this will be an actual letter, actual character. So passing a single char, I make the space for it, and then I say if the current character in my regex pattern pointer is a backslash, that's annoying. I have to escape the backslash, don't I? If it's a backslash, then s is escape equals true. I should increase the pointer to point to the next character. I should pass the escape. Did I say escape? Escape. There we go. Escape char, given the regex pattern. And s is escape. Escape char should equal that. Yes. For some reason, the word escape now looks really weird to me. And s at the char data should be like 0. I mean, I think it's not really necessary to do this right operation, because the idea is since this is set to true, I should never really look at this. Oh wait, is this what unions is for? This might be more helpful, I think. Because like basically what I'm trying to do is only one of these two fields exists. It's either the escape char pointer exists or the char data character exists. I forget how it works though. Like, how do you? Data.i is corrupted, yeah, because you overrode it. But then, like, how do you remember like which field you just set? You know? I won't do it for now, but I think it could be something. So if it's an escape char, do all that. Otherwise, it must be some single character. S is escape equals false. S escape char equals whatever the regex pattern is at the moment, and then regex pattern increases by 1. And again, I don't know if I have to do this, but S at the, wait, hold up, this is wrong. This is char data. At the escape char, it should be set to null. And then we can return S. The single char. Okay, passing a single char and passing the escape char. So we've passed the star already. And then pass the escape char star regex pattern. Alright, so switch on the character I'm on at the moment. Case, is that wrong? Case, different cases. Dot, and I want the cascading idea. Case dot, case star, case n, case t, case s. I didn't really talk about s, but anyway. How do can I do this? Blah, 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 blah. What am I doing? Escape char e equals malloc size of escape char. That will fail. So I need to define the struct. Char data. So with any of these, then e char data is just equal to whatever it is. That's fine. And then I just break. Default is like, with the colon, sorry, my mistake. Default is like fprintf standard error. I believe there is an invalid escape sequence. Exit 1. In fact, I can just return E at this point. I don't have to put break. Yes. Okay. Oh, something is seriously broken. Why are there so many errors? Eh? What is happening? Oh no. What? What just happened? Did I type something weird? Let me copy this. I'm just gonna undo until things go back to normal. Ah, it's probably because of the semicolon. Okay, that freaked me out for a second. And paste this back. Okay. Okay, so I think I've written up the basic idea. Wait, did I move the pointer across? I should move the pointer across. This will consume this will consume the backslash. This will consume the particular character. So wait, which thing is responsible for concatenation again? This guy, so sub expression. It'd be great if this worked first time, but somehow I doubt it. So we're going to expression equals pass the expression given the regex pattern. And the idea is I should have a pointer to an expression, which then points to all. I should basically have this tree. It's what this code is meant to do for me. I'm meant to have this tree. So, what's a good way of doing this? I could make like a print. Void print the tree given an expression pointer. Okay, so printing stuff is very fun, isn't it? I have to. So given this tree, which I hope is correct, I will have this guy, and I'll ask, okay, I know that I'm in like the top generation, then I will print expression, whatever that means, and then I will print and then I know it has 2 pointers, so I'll say sub expression or expression. Within sub expression, so it's visit left or right, so it's a pre-order traversal. So I'll do expression, then I'll visit sub expression and print that. I'll visit char, print that, block, print that, single, print that, r, print that, backtrack back to star, which is empty. So I won't actually put anything. Maybe I'll just put empty. I don't know. Oh man. Okay, I generally do this recursively, but it's basically just a DFS. But I don't. I'm so bad at doing. I'm bad at doing this stuff recursively. I mean, iteratively. But I should. I need a stack. Ugh. No function overloading or anything. Wait, okay, let me remind myself how to do this. It's been a minute since I've implemented this iteratively. So I need a stack to basically stand in the way of the call stack. So you have the expression in the stack. You pop off. I think you have to pop this one off and then you have to replace it with the OR expression and the sub expression, right? So that one's gone because you popped it off. Popping off is equivalent to printing. It's like the visiting part. So you print off expression, then sub expression comes up, OR expression and sub expression comes along. You print the sub expression and you push its kids on, sub expression and char expression, char. You pop off char and put on star and block. You pop off block. Where's my tree? You pop off block, putting on single. Wait, a block is just a single? Oh no, but it can be one of the, yeah. Block becomes a single. And a single gets popped off for an R. And the R gets visited. Then you go back to star. Yeah, I think this makes sense. Back to char, back to sub expression. And then you have star. Where does star come from? This guy? Wait, what? Why do I have star written here? Okay, basically, I think you push the right child and then the left child so that the left child gets visited first when you pop off the stack. And that should be fine. I need a stack. Oh god. This would, I guess, my the thing is, like, this has like how many nodes? How many pointers? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I don't know, like 30 or something. So it can get quite big quite fast. So I'll say 500, which is quite a lot to be fair, but it's fine. Max stack size. And then we say, can I say void star? Is that valid? No. Oh wait, it's probably. It's probably something weird to the multiplication. Eh? Oh, I put equals. I put equals. You don't put equals. There you go. Okay. So we have a stack. We're going to stack dot. I should have a size. Stack at 0 should equal expr. What's wrong with that? Expression must be a modifiable L value. L value meaning it is a loaded address. Are you not a loaded address? Is it because it's void? If I said like int star and I said equals 3, you'd be fine with that? That's annoying. But I don't know what kind of pointers I want. Just to clarify, it's a stack. Ah, double pointer. Is that why? Does that help? Yeah, come on. Yes, because it's an array of void stars. It's not that's worse. Yes, I understand now. Yep, and then size equals 1. Int, that is. While there is something in the stack, I need brackets. This is in Python. While size has something in it, Oh, but there's no. I don't have any way of. I don't have any way of actually knowing what the pointer is where I'm up to. Do I? Is it possible to determine the type of a void star from in C? No. Well. Yeah. Okay, so my stack idea might not work. What if alongside it you have like a string thing? Like you push the type or something. Like you have another stack which is exactly the same except it's a bunch of strings, and those strings tell you what the type is or something. A bit hacky, but it's C. What can I do? So we'll call this the node stack, and we'll call this the label stack. And this is an array of strings. So it's char double star, and this is called the node stack, and label stack at 0. Can I just say, can I just do that? Okay, and instead of blatant strings, I should make an enum. Enum node type nt_expr. Ah, fair. Okay, so I don't think I actually need the strings then. Nt, so I need one for each. Nt or expression, Nt sub expression, Nt create a block expression, Nt block expression, Nt single char expression, Nt star, Nt escape. And then, but then I also have to be able to print like the actual character themselves, right? So Nt char, I guess, would be my last one. Okay. We're getting somewhere, I think. So instead of label stack being char stars, it will be, what was the enum called? Node type double pointer nt expression. Void star current is equal to node stack size -1, because size -1 tells us the last element. We need to decrement size immediately to accurately reflect popping it off the stack. Then we'll use a helper. I don't know what the helper should be called. Cast the node. Given a particular node and a node type. Wait, does this have to be? It's an array of node types, right? I don't need double star there, do I? Node type nt switch on nt case, and then I have to do all of these. Oh, no, please. Don't make me do it like... Thank you. Wait, first things first. Put a dot thing here. Second thing second. Do that. Case. Bing, bong, bing, bong. Bing, bong. And now I might have to do it one at a time. What? No, give me the insert mode, bro. Oh, I'm pressing escape, not tab. I'm so confused. All right, and I'll do default again. Yeah. Switch on NT. So if it's an NT, this doesn't need indentation, does it? I don't know. Switch on NT. So if it's an NT expression, then maybe instead of just casting, I have to actually do the printing as well. Print node. Which means I might also have to talk about like might need a stack as well. Node stack. The node stack, and I might need the label stack. Okay. So okay, now we're going. So expression. We're going to cast node to that. Okay. Expression star e is equal to that. We're going to print f expression with a new line. We're going to print f. I don't actually know what generation I'm in. So I don't know, like, because I wanted to use like indentation to be able to like indicate, you know, what generation I'm in. Like it'll be like no indentation, 1 indentation, 2 indentations, 3 indentations, 4 indentations, 5. And then 3 indentations, 2 indentations, 3 indentations, like that. It's for the printing, but I don't actually know what generation I'm in. So that's a bit annoying. So I print expressions, and then I print, no, not, and then I need the size, int star size, stack size. Node stack at size equals e. I need to dereference e right child, or, and then also sub. So yeah, I push the right child on first, because pushing the right child then the left child will mean the left child gets visited first, which is what I want. It's a pre-order traversal where left child is prioritized over right child. So yeah, I think does that work? And then I think you can just return out, right? And I have to do that like 70,000 times. Ooh. Okay. I shouldn't say e, sorry. The or expression. If the or is empty, if it or is empty, then you should return. So maybe I should say if or is not empty, then you should push onto the stack. I need to do the label stack as well. Which means I can't increase the size yet. Label stack size is equal to NT or expression. Then I can increase by 1. So I'll do this and then increase by 1. And this. NT sub expression. Okay, if it's not empty, then node stack at size is equal to, or given the particular expression that we need to pass this guy. And the label stack at size, and we increment as well, equals NT expression. And then return out. And if it is empty, then I guess we don't have to worry about anything too much. Okay. Sub expression. So we need to first put the sub expression in, because that's the right child, and then we have to put the Then we have to put the repeated block. Yes, I should print in sub expression, and then I should return repeated block. Blick block if, what are the fields again? Block or star. So it's just, it definitely has a block and a star, right? A repeated block, where is it? Char became repeated block, right? That was the thing yeah. So yeah, definitely has a thing. So push the star first. Push the star first, and then push the block. Yes. Then what's the block again? Just as a single? But it can also be the expression thing. Yes. Okay. So block star block is equal to block star node printf block node stack size is equal to block type if block type is equal to bt single char type, then block data, and we can cast it as a single char star nt single char. Else if, of course, maybe I don't have to be explicit because there should only be two types, but it's good to be explicit. Pew 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 pew. All right. Express. What am I doing? The XPR, right? Oh, this is getting like this is getting really stupid. But yeah, blocks can either be single characters or they can be an expression in brackets. And we push that onto the stack. If it's a single char type, then we can printf. I should be doing backslash n, right? We can printf single char. You can also do the cast. You can say single char is equal to single char node. If single char is escape, then we'll do this. Yeah, we'll do it as follows. The escape char pointer, right? Don't need to cast anything. Nt escape is escape. If it's not escape, then I think I can just straight away printf. I think I can print off a new line here, because I didn't print off a new line yet, because I want to, if it is an actual character, I can put an equals like equals, or maybe like an arrow, %c, then the new line, where the %c is the single char, and it's the char data. It's the actual character that it holds. And if we have managed to get the single char, we basically got through here and printed this out, or printed this out. If we manage to get to there, then there's nothing more to push onto the stack. I think we can kind of move on with our day. And then we have something like this. If it's a type star, then star is star. If star can be empty, right? If not star is empty, single char star. If not char is empty, then printf some arrow star. And again, the star struct shouldn't have any pointers to point to. So that should be it, nothing to push. NT escape. Sort of similar, right? Was NT char just my way of trying to handle the character? I don't think I need it. I don't think I'm going to push NT char. I'll just write... I'm just using that arrow thing. So like when I get to a character, I'll just be like, I'll print it at this level, and I won't bother making another child. So yeah, get rid of NT char for now. Maybe it'll be helpful in the future, I don't know, but give me my error. Get rid of you. And then NT escape, we gotta do the cast. So escape char, escape. What are the fields again? Char data, print f. Escape char backslash followed by a %c, new line, escape char data, fair game, and then default fprintf in print node found a weird value for NT and exit 1. Okay. Should this be nested inside like this? So much nesting. Okay. Okay. I have to also keep track of like what generation I'm at. I could have a struct that keeps track, like that holds a void star and an int for like the generation number. I don't know if that's dumb or not. Probably is, because like, what's the point of that? What's wrong with that? Too few arguments. Oh, I'm supposed to put the standard error. The other option is just to basically make another stack. It's an array. So it's the generation stack. And then I'll just free everything now before I forget. So yeah, node type int star generation stack. could definitely clean up this function a lot. But for now, just want to see if it works. So void print the indent given the generation number for int I equals 0, I less than generation, I plus plus, or plus plus I. All I want to do is print like a hyphen or something. So we want to I kind of do the popping before I actually, like I pop the values of the stack in the beneath function down here before I actually call this function, so I should probably have the generation number already. I'm hoping my grand plan was to do this, pass the generation number in, and then every time my generation stack at size should equal generation plus 1 is my, I'm praying that makes sense, because I always have the current like parent, I'm always pushing on the kids of that parent, so the generation of those kids should be plus 1, and I basically just have to do that every time I push. Could this be its own function? Most definitely. Am I going to write a separate function? Absolutely not. Why is there such weird indentation going on? Just give me the thing. Thank you. How many errors do we think? It should be a gambling thing. Pushing. Any more pushing? Let me look for any place that says size plus plus. Okay, I've done that one. There's nothing beneath. Okay, I've done that one. I did 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 that one. Okay, yeah, I got them all. Oh, I have to actually call the function as well. So I have to, so I've got the current thing at the top of the stack. I have to print that node using the function print node, given the node, which I called current, given the type. I should probably node type nt is equal to label stack size minus 1. I hope. Hold up, wait, did I use the wrong value? Should this be size minus 1 again? It should be, shouldn't it? Crap. Oh no. Am I right? Because like size is the size of the array, or of the number of, it's like the number of elements currently in there. Oh no, that's fine. That's the number of elements currently in there, so the next index to push is size. No, that's fine. Sorry, that should be fine. Because if there's 5 elements, that means the size is 5, which means index 5 is the next element to push. Yeah, okay, it's fine. Sorry about that. It's when you pop, you have to subtract 1 because that's where the last element is located. Whoops. Okay, that's fine. And then I've got that, and I've got int generation equals generation stack size minus 1. Okay. Nt generation node stack label stack, generation stack, and an address and the address of the size parameter so that I can read it and edit it, and those changes are reflected back into this function. Fantastic. I print the node and the stuff gets pushed and the generation information gets pushed and the label information gets pushed of the kids. Okay, I have code written. Is it correct? Absolutely not. It's 9 o'clock. I started at about 7:30, didn't I? 6 o'clock? When did I start? I have no way of checking how long I've been recording. But here we are. clang parser. Output parser. Oh no, I have a warning. Whoa. Must have forgotten to change the... How often did I do that? Once, apparently. Oh no, it's even worse. If there's no errors, that means I'm going to get a seg fault and I'm going to have to use sanitizers and stuff, and I'm not going to understand the output because I'm sleepy. Wait, if I do this, is this an error? No, it's not. Split the line to keep it from being 80 characters. Oh, that's annoying. This is an error because strings shouldn't be split like that. But if I put a backslash, does that help me? Yeah. And this doesn't count because it's a comment that I'm hoping to get rid of eventually. So first things first, if I do this, good, I get a usage message. Let's first begin by being really brave and putting my initial example, which was rk star \n pipe b dot. What? Excuse me? Ah, because something about... There it is. Alright, first things first, let me just make sure the entire thing is being printed correctly. Also, I didn't check for a lot of error cases, you know, but it's fine. For char star c equals argv1 or argv regex pattern, c is not equal to the null terminator plus c print f percentage c C, and then printf a new line. I just want to see if the whole string gets passed correctly. Nothing weird happens. Let me compile. Okay, good. So the whole thing gets passed through. So at least I didn't mess that up. I didn't mess up the easy part. Oh, now I have to debug. How fun. How far in do we think we got before we crashed? I think we managed to create the expression node. Right? Like we have this function. Oh, we didn't even call the print function. So it couldn't have been the print function. Okay, so we barely even got through. We call the pass function. I reckon we managed to get the pass function, and then I think it would have crashed as soon as we got into here. We would have tried mallocing, and then it would have gone into here. Probably would have gone to repeated block. Where's repeated block? There it is. Right beneath. Repeated block r equals malloc size of repeated block. we were to try to pass a block. Alright. Good news is I think I know how to use sanitizers. So I should be able to figure this out at some point. First I'll try debugging. I need breakpoints, don't I? Ah. Oh. Wait, how do I give the... Okay, I don't know if it's worth it, but maybe I can be like... If I say... Okay, just for the sake of debugging, if I get rid of all of this, and I say char star regex pattern is equal to this guy, just to clarify, that should work, right? As in, it won't work, but I mean, it should. That shouldn't be the issue. That way I don't have to worry about how to... I should know how to do that, actually, but... Okay. Yeah, I should have known. I tried something dodgy, it didn't work. Whoa. SP is not available. Alright, so... Should I... Let me go like... Let me start from the top, you know? Let me put a breakpoint right in here. Let's try that again. Let's pause it. What? Okay, never mind. Oh wait, hang on. I think I have to put it here. Sure, mate. Alright. So what have we got? We've got an S. Yeah, we've got the sub expression. We got E. We got the regex pattern, which is an R, which makes sense because the thing starts with an R. Very good. We go in here. We have to malloc stuff. Is it a pipe? It shouldn't be. It is not. Then the sub is empty, is false. It is not empty. It is full of life. Then we have to create a repeated block. We make the repeated block. We pass that block. All right, here we go. This is where it broke, right? So the regex pattern should still be pointing to R. Very good, but still looking at the R. We're going to check if it's a bracket. It is not. So looking at the block type, it's a single char. Else, it is a single char. BT single char type single char. BT data parse single char. BT single char type, because it's a single char type, right? It's a single char type, not an expression type. So single char type, we're going to pass the single char, we're going to malloc. Is it a backslash? It is not. So it's not an escape. It is char data, and regex pattern should increase. Notice that's moved to K because we've increased this one. And we're returning S, where S is a particular address. That looks pretty legit. Char data is R. Escape char is null because it's not an escape char. Fantastic. We go back to here. Oh crap. I have noticed that this has not updated correctly. Which I think does make sense, actually. Because it's a copy of the address, so that didn't update properly the way I hoped. Which is unfortunate. Do I have to pass in like the address of the address? It has to be like a double pointer? That's quite annoying, isn't it? And then this is where it breaks. Oh no, it's fine. Okay, well, I am seeing a bug anyway. The fact is, the regex pattern isn't being updated like everywhere. It gets updated like in the moment, but then when you return that update, it makes sense because you're in a different stack frame or whatever, so the update doesn't carry. So maybe that's something I can fix regardless of what's happening. Unfortunately, it seems that it has to be a double pointer, a pointer that points to a pointer that points to the current character, so that when I do the update, that update reflects correctly. What? Why would I? What? What? Okay. Whoa. One, two, three, four, five, six, seven. One. Wait, what? 1, 2, 3, 4, 5, 6, 7, 8. Why is it 9? 2, 3. Ah. Okay. I'm just gonna come back here. I have to double dereference now. Okay, so when you regex pattern plus plus, you're actually regex pattern. So yeah, whenever you regex pattern plus plus, you're actually dereferencing, thereby getting back the original pointer and increasing that. And this has to be doubled. Double dereference. There must be a better way to do this, right? Like, double dereference. Regex pattern, I pass in the double pointer and then yeah. I access the memory and move that pointer by 1. Increase its address value by 1. So that whatever, yeah. God, this is tripping me out a little bit. It's been a while since I had to do stuff like this. I don't even know if this is like what you're meant to do. This might be completely like stupid, but dereference, double dereference. What if I do like something like that? Okay. I say regex pattern 50 times, including the so double pointers everywhere. Double pointer, double dereference, single dereference, the increment, pass the pointer, double pointer, double dereference, pass the pointer, double putting, pass the pointer, double dereference, increment, pass the pointer, double dereference, increment, this one, double dereference, increase by 1, pass the pointer. This should be double dereferenced because I'm trying to get the original character out. Increment the character, char double star, double dereference, increment, double dereference, check again, this, increment, bingy bang bong. This is fine, as is this. Am I a little bit concerned that... Alright, imagine it just works. Aww. Wait, what? Ah, of course. Apps. Because it's double pointer. Damn it. Well, it's a little better. Actually, it didn't just crash on me. It actually gave me something. So, I believe... Interesting. So, it should have incremented the regex pattern. Okay, let's debug. Maybe I can just... Maybe I can put the breakpoint like in here? If I can get away with it? Oh wait, sorry, I forgot to get rid of you. Go again. Okay, so where are we at? Regex pattern points to a backslash. Okay, so we have hit the backslash, which means, you know, sorry, I just want to check something. So the string looks like this: arcades backslash n in a pipe b dot. So what are we up? What? Pass the expression, pass the OR expression. Why are we passing the OR expression first? It's not. No. Pass the expression. Why does it look like? Doesn't it look like it's passing the OR? I'm very confused. Okay, anyway, we're up to the backslash n. That's fine. Regex pattern increases by 1. Okay. That is not good. I've managed to make the pointer point to -24. Excuse me? How? It managed to iterate completely fine the whole time. It went through R, it went through K, it went through star, and it got to backslash. But when it was time to go to N, and I ran this thing, you're telling me I dereferenced, got to here, increased this value by 1 byte, and now it's pointing to -24 dash whatever that is. And then naturally, because it's not correct... Oh, I pressed the wrong button. I'm not sure I really follow what just happened. Why is it not... Huh? There's a lot of calling sub-expression, I feel. Like, what is happening? Like, this doesn't look right, right? Like, why is there so many? I know the tree is kind of extensive, but sub-expression specifically should only be called 1, 2, 3, 4, like 5 times, 6 times. So, do I really have to run it from the top? I don't want to, but I feel like I need to understand why it's doing it so many times. Like, I'm assuming the backslash, I made the assumption that the backslash is referring to this backslash, but maybe it's not. Maybe it's just found, it's happened to find a backslash because it's being weird. So unfortunately, it might be that I have to do this. And it might be that the double pointer actually made things worse, not better. Which means my understanding of pointers themselves is a bit dodgy. Okay, but it does point to R, which is good. Oh, wait, it goes through that entire thing, no problem. The regex pattern is this guy. Hold on. Wait. Actually, I didn't mean to click that, but okay, so it gets to the pipe. Again, maybe it's just happened to hit a pipe. Null terminator. Okay. Again, it should have found a B, found a null terminator. Okay, so as exciting as that was for half a second, I do think I have to run through everything. Okay, dig in. Bing, bong. Again, check this guy. It's an R, right? Bing, bong. Bing, bong. Bing, bong. Bing, bong. Bing, bong. Bing, bing. Bong? K. Okay. So it moved on to K, didn't it? Fantastic. Turn the S. What does this address? 100. Eh? Where did this address come from? I guess it's the... Ah, yeah. It'd come from... Okay, fine. I think that makes sense. Pass the star. Is it this one? No. Then it's an empty star. Oh, that shouldn't have happened, should it? Hold on. Should it be... If I pass a star, and there's no star, and there is a star, sorry, is empty as false, I should move on in that case. Shouldn't I? Blunder by me. Otherwise... Right? Alright, let's do that again. So, bing, 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 bing. Bong? I can go through that, right? Because pass the sub-expression. It's not a pipe. The repeated block. Pass the block. Pass the star. Is it a star? No. Wait, what? Wait, did I jump over more than I realized? Was me being impatient actually a bit of a problem for me? We're up to the backslash. Pass the repeated block. Pass the sub-expression. Where are we even up to? Maybe, I mean, since it's backslash. Maybe up to here now? Remember, char and repeated block are the same thing, so I think we did this and we're up to here now. Shit, did I... Oh, I think I... Did I press down or what did I just do? Is escape is true? Oh, because it hit the breakpoint. It happens at the breakpoint. N! Oh! Crap, I didn't go... Oh, I didn't go in. Okay, that's fine, that's fine. But it did... It hit the N, and I'm assuming it caught it correctly. That's the... So it hit the N, and then now it's a pipe. So B data refers to getting that single char node. So this should say no. So it's like an empty. Oh crap. Oh crap, that's gonna be bad. What was a pass star? Wait, what? Why is it not sure? What did I just run? Oh. Why is it not sure? What is this? Pass repeated block. And then you get B and you get S. Yeah, so S would have come from pass star. Maybe it just hasn't run yet? Oh yeah, that's actually assign it. Sorry. Is empty is true. Good. Okay. Bing, bing, bing. Pass the repeated block, pass the sub expression. What is the regex pattern again? The pipe still? Okay. What is happening? Why is it going over and over through here? We did say that the call stack was like continuously growing, right? Okay. I'm gonna assume that was meant to happen. Pass the OR expression, here we go. If it's an OR, it is. B, very good. Pass that expression. I'm gonna pass the expression. Pass the sub-expression specifically. What? Okay. Regex pattern should still be on B. Good. Pass this repeated block, which is that B. Pass the block. It is not a parentheses. It is single type. Single char. Oh, I should have. Anyway. Pass the block, pass the star. Should be empty. Empty is true. Return that star. Child sub. So does this now point to the new thing? Yes, it does. What just happened? Okay. Maybe clang? I don't know if I compiled. What? Where? We went through that whole thing and nothing bad happened. Maybe I can print a bit more information. Hang on. Regex pattern currently at. How did I do that? What the heck? So it's literally just some random character. Okay, well, I think the ideas are there. I have to go through it more slowly, I think. I'll probably debug in my own time then.